So let us start. So good morning to everyone, and first of all, thanks for the opportunity. This is my first Postgres talk. Previously, I have done multiple talks on other technologies. This is my first Postgres talk, and that too on a migration. So I'll try to cover this as this migration was done by me. We have a huge experience on this migration. This is my first Postgres project. Let's get into that. Uh, Here we'll see about how we did the migration, what are the major challenges which we face, and what are the planning things we do, what are the workaround on this migration, and multiple things. This is about me. So I have around 13 years of database experience. I started my career as a MySQL DBA, and then from there I switched to distributed SQL. That is, I started learning TiDB. I'm the first TiDB certified professional in India, and I started Yugabyte. And last 2 years, I'm working in Postgres, and also learning other technologies as well. So first, what we'll cover in this migration topic is why was the migration decision taken? What is the rationale behind migration? And how did the client engagement begin? What was the context behind the migration? What is the scope and what is as a subject success objective which was for this project? And what are the toolings which we evaluated and which tool we finalized? And what is the execution phase? What is the execution methodologies we use and how did we do the cutover along with the rollback strategy? And also finally, we'll discuss about some of the challenges which we faced and how did we overcome around that. So first thing, why people are moving towards uh, Postgres, right, from Oracle. So there's nothing wrong with Oracle. So Oracle, you cannot compare Oracle and Postgres. Oracle as a database is very, very mature and highly performant, and there is no direct equivalent to Oracle. But the thing is, we can have some workaround and we can move the database workload from Oracle to Postgres. Okay. So what are the major drivers behind this migration? Is migrating from Oracle to Postgres is the cost. The major thing that drives is the cost because Oracle comes with an Oracle exclusive licensing enterprise and various levels of licensing. Even when you want to use features like data guard, everything is licensable. Like it comes with a different set of costs. So this is a major factor that pushes for the migration from Oracle to Postgres. And the next important thing is vendor lock-in. Like in Oracle, when you are into Oracle, when you started using more and more features of Oracle, such as PLSQL, the people tends to write the application logic into the database. Okay, that is when the lock-in starts. Like when you start using more and more enterprise level features, it makes very difficult to come out of Oracle. Okay. And to avoid that vendor locking, people are trying to switch from Oracle. And also as a part of cloud modernization, like uh, moving towards AWS or Azure or GCP cloud, as a part of modernization as well, people are moving out from Oracle. And the other important thing is a strong open source presence with respect to Postgres and also the vibrant community and the enterprise grade features, which is inbuilt with Postgres is also a driving factor. And next important thing is the agility and engineering things like when a developer develops a new feature, like they want certain features that needs to be enabled. In case of Oracle, they have to get a new licensing enabled for that feature and build. But it's not like that with Postgres. Like with a new extension, you can build a new feature or with a custom code you can write your own logic and define your functions as well. So these are the driving factors between Oracle. So next we'll discuss about why Postgres specifically from Oracle. So there are multiple other databases available in the market, right? Why people are moving from Oracle to Postgres specifically? What are the reasons behind it? The first is the architectural similarity. Oracle and Postgres, the underlying architecture remains the same. The dialect, let's say, interact is pretty common. This is first thing. And the next important thing is the enterprise grade features is completely free and available for Postgres, like with extensions and other workarounds and other features like, and also it is very much compatible with the latest ANSI SQL. This is also an important factor behind the migration. And other thing is like Postgres is the true open source. What meant I say true open source is like if you say MySQL is also open source, but it is locked with Oracle. That means Oracle controls the development of MySQL. But in case of Postgres, it is completely community driven. There is no single company or entity which is controlling Postgres. Okay. So this was also an important factor for choosing Postgres. And next thing is the reduced infrastructure dependency. For example, when you have a Oracle rack, right, so it needs a dedicated hardware, it needs set of storage requirement to get started with Oracle. Okay, but not with respect to Postgres. Even a small machine like a commodity hardware in Kubernetes, cloud native, wherever you want, you can deploy Postgres and use it very easily. And also the major cloud providers also provide managed services like Aurora, RDS, Cloud SQL, Flexi servers, multiple. So there is the option is very vast. And coming back to the final point, that is cost. The cost of ownership of Postgres is very low comparing Oracle. So next, from here, I'll just share my real world use case, which we did for our customer. So first is the engagement. We started discussing about this project. I'll just give a background about what this customer really does. So they are into the insurance space and one of the leading insurance provider in India. Number one, specialized in the health insurance thing like hospitalization, cash free, and those things. Uh, and they have 7 product lines: health, accident, maternity, travel group, multiple other others of insurance policies and multiple things. So as a part of the cloud modernization, right, they wanted to move the on-prem setup to the AWS. Okay, AWS Aurora specifically, and also this is an AWS funded project. So that was the rationale behind the migration. Okay. I'll give a small introduction about source and the target Postgres which we are going to. So the database version on the current on-prem system is the Oracle 19c version, and we had targeted to move to Aurora Postgres. And it was the HA deployment was it was a 2-node rack cluster. In Aurora, we have the managed disk, that is a high availability storage disk, and 15 terabyte and multiple other things are available. And the database size in the current Oracle system was 20 terabytes of data. And the customer do not want to move the entire data. They wanted to move first. They wanted to move the live 6 months of data, and they want to backfill the data back from Oracle. So this was the engagement, and they had around 2,000 schemas. Sorry, 2,000 tables across all the schemas, multiple schemas, and they had all the objects like views, procedures, triggers, materialized views was also there, crons, scheduled jobs was also there. And with coming back to HANDR, they were using a 2-node rack cluster. So rack, you can write on any node and read on any node. The storage is common. So there's a real-time application cluster. In Aurora, we have a similar setup that storage is common. You have the compute nodes and you can upscale flexibility and everything is available. And backup, they were using ARM and exports. Here we have the managed backup, that is snapshots. And similar to monitoring, they have the OEM and AWR reports, which is generated in Oracle. And monitoring might be up to the managed monitoring for the Aurora along with the CloudWatch setup. Okay, so this is the high-level background between the source and the target. The first thing, customer defined a set of success criteria for this project. First thing is functional compatibility, like whatever the code which runs in Oracle should run on the Postgres. That means the code should be matched and the result set should be same and also matching the performance. This is the first criteria for this migration. If there is a small deviation, the migration is stopped and they will have to roll back. And again is the data consistency, matching the data between the source and the destination. So there is a small catch here. I'll just explain. So we had in Oracle, the numeric data type, that is the number data type, handles both the numbers, that is numbers and position point. But in Postgres, so we have to use between integer, float of it, multiple is there. Now when we migrated, like the SCT, we are using the SST for the initial assessment. So the small data inconsistency issue that we saw between the precision values that is being stored, as it is an insurance customer, right? So they have to store values like amount in most of the cases. So that was giving some issues, but we had written a custom code to fix this for the data inconsistency on the specifically on the floating values. And the next important thing is they want to reduce, as it's a live insurance application, right? So the downtime or the cutover windows should be very, very minimal. They need to have a live replication between the source and the target. And performance stability, like there should not be a case like this code was running fine and it was giving 2 second performance in Oracle, but it was taking in 10 second or 5 second and breaching the SLA. The performance stability should be also be matched with respect to the Aurora. And operational readiness, obviously the backup everything previously covered it, it should be there. And rollback safety. If in case of like post cutover, if there is an issue with they see on a security or any functionality, critical functional is not working, they should be able to come back. So this is the objective that defines the success of this migration. Third is we had a brief discussion what kind of tooling to use, and we'll come up on this. There are common tools. Obviously, we use the AWS DMS, but I'm just giving a list of tools which is available in the market for assessment. For assessment, you can use Aura to PG. This is an open source tool, and EDB migration portal and AWS SCP, which is also available. You can download it and install it local. So assessment is basically it connects to your source database, run some certain assessment. That means the number of objects and gives a health check kind of health check report, like discovering the complexity, that is simple, medium, complex, and what are the number of objects available. Those assessment report for the migration, whether it's migratable or you need to do a workaround, those kind of initial preliminary set of assessment is provided by this tool. And second is schema conversion, that is converting the Oracle dialect to PostgreSQL dialect in terms of structure, like the DDLs, the table structure is done by this. So again, Aura to PG is well compatible. Next comes the AWS SCT2, and EDB migration toolkit is also does the same. And third is the code objective. The important point of this migration is the code objective. You can migrate the DDL, you can migrate the data, but the functionalities like the procedures, the application functionalities, which is written in the Oracle database, right? So rewriting that is a major challenge. These tools, what I mentioned, right, Oracle PG does a good job uh, up to like 60%, we can say. The remaining 40% is like planning or collaboration between the application team, TBA, and developers as well. Like they have to collaboratively write a code and match it. Okay, there is no direct path or direct tool that supports 100% compatibility of movement of all this code. It is not available yet. And data migration, obviously the best among the tool is DMS, AWS DMS, because I will discuss that later. We use DMS for this project as well. And also DMS supports CDC, that means live replication is possible. Oracle Golden Gate also does the same, but it is a licensed tool. So you have to pay for Oracle to get that. And WCM is obviously an open source tool. Validation, DMS comes with validation, like count validation between the source and destination at a table level, schema level is possible. And also other checksum tools is also available to do the same. Automation, obviously you can write your own automations to for this project. Means whatever the skill set you have, you can write your own automation tools on the frameworks. Okay, so why we chose AWS DMS? For obvious reasons, this is an AWS modernization project. So we have to go with the DMS, and also like DMS supports both full load plus CDC on a single task. You can also do a separate level task as well. Only replication, that is only CDC, only full load is also possible. Managed migration service, it's a managed service from AWS, wherein nothing has to be done for you. You have to provision the instance and start using it. And monitoring is done by CloudWatch. You'll have a dedicated set of monitoring to see the throughput, load, number of requests has been transferred, and multiple options is there. And it also supports larger migration. In our case, it is a larger migration because we have to migrate, scan through 20 terabytes of data and migrate it. And also it supports a partial migration. Like uh, in a single table, you can write your queries. That means you can have a condition-based migration. We discussed, right, last 6 months of data migration is possible with AWS DMS. And it also integrates very well with the AWS ecosystem and built-in validation support. These are the major reasons driving behind choosing of AWS DMS for this migration. Okay. So next is the how did we execute the migration? Means this whatever I'm explaining, right? So this might be a 25 to 26 slide, but this migration, there is a real migration ran for around 1.5 years. So first is the identifying the objects, okay, identifying the object is there in the source, and have a clear-cut plan. So what is supported, what is unsupported, what is the complexity, and what are the objects and what are the part of code or part of things that needs to be moved to application. Like in, for example, um, in Oracle, the MV refresh is automated. It automatically does the MV refresh. But in Postgres, we have to define some cron jobs or scheduled activities. Like the initial loading is much higher time consuming and multiple things are there. So this has to be handled. How we do about that? What are the unsupported features? Like there are clear cut of certain things that is not supported in Postgres. So those has to be rewritten or the logic has to be written. This first identify these things and have a clear plan and proceed upon the migration. So next thing we did is the structural migration, that is schema conversion. So here are some of the dialect based on the your data type, right? You can choose a data type accordingly and choose for the detail like number, numeric. There are multiple options. And when you do a AWS SCT, it uses a generic level of data types. Let's say for float also it uses number. For integer also it uses numeric data type with Postgres. So it is very generalized. Do not go with the report what SCT provides. Okay. Just once you get that, you just validate the source data, what kind of data it stores specifically, and choose your DDLs accordingly. Uh, and for simple use cases, SCT is good. But for large use cases like complex data types such as blobs, like byte, handling glob, and those things, like you need to define your custom data types with respect to the table. Okay. So next is the code conversion. So here is the major challenge lies. So there were around uh, close to 400 objects as a part of this. There were around like 168 views altogether for this project, and some 200 procedures, odd procedures. Some of the procedures were also duplicated. We discussed like they can be moved or things. And the important thing is, as it's Oracle 19c, right? They were using a legacy code object, like as you can see in the screen. The left join or the left outer join is measured by plus symbol, right? When we give to this code to the A or some other tool also, it does not convert it exactly. Uh, there is errors. Actually, when you run this code in Oracle, it gets a different set of result. And when you do the converted result, it gives a different set of result. So we had to sit with the developers and change this, like the legacy code, and to get the exact application logic, we had completely rewritten all the codes. Not all, like some 40 to 50% of the code dialect were rewritten with respect to Postgres. Like for example, this plus symbol we changed as a left outer join on this syntax, and we pushed it. And again, important thing is maintaining the performance, right? So we created an index which is specific to Oracle, but there were also certain other new type of indexes and new composite type of indexes which has to be created based upon the performance of each component. Let's say because the optimizer is variable between Oracle and Postgres because that's an enterprise grade uh, optimizer, right? That has a different set of plans. And another important thing is Oracle also supports inbuilt analytical as well with respect to RAG. That we for Postgres we used Redshift. We shifted some of the data to Redshift to provide the same analytical functionalities. Okay. First, and the next important thing is now the structural part is fixed. That means we have the DDL. Now we have the code. Uh, then we started segregating the tables. Let's say we had around 2000 plus tables. So we, along with the application team or the development team, we sit together and segregated tables. So all the data might not be needed. Like there are tables for which only the structure is needed. Okay, there might be dynamic table, the structure, the data is populated on the fly when the application runs. Identify those tables, move only the structure. And next is the config set of tables. For tables which does not need a replication, that needs just a one-time loading from Oracle to the Postgres. And next comes the segregating the table based upon the size. We segregated tables based upon size, let's say less than 10 GB, 10 GB to 20 GB. And then from 20 GB to above, we started creating each individual task per table. Okay, that is a DMS task. Because just detail explain that. So uh, and for tables, transaction tables, and also define the tables which need replication, which does not need replication, like one-time load does not need a replication. And for transaction tables, it needs a replication. So we define those properties in the DMS task. And and also again, one more thing to see here is when you enable a CDC, like when you want a live replication for those tables, it is mandatory that you need a primary key on the source. If primary key is not available for those particular table, you need to have the supplemental logging feature enabled in Oracle side. And also we need a set of archive logs. If let's say if the table size is very huge, if the migration, like the initial load, runs for let's say 2 days, at least we need to have a retention of 2 to 3 days of the archive logs. That is the change logs in the Oracle side to manage the ongoing application. If the archive log is not found, the CDC, there will be CDC failures. Again, you have to do the fresh reload from the beginning, increasing the archive log. So this is a catch here. And yes, before you do the production migration, so we did a couple of UAT migrations. That is UAT, beta, and then production. So first we fixed the schema structure. That is, this is the structure that is going to be never changed. And also during this start of migration, once the migration starts, we had requested the customer to stop to have a change freeze on the source side. That means no more new additional columns on the Oracle side. The structure should be freeze. Even in case of a critical patch or critical release, they need to do the structural changes. That structural changes have to be well informed to us so that the same structure goes to the Postgres as well. Okay, so that was the agreement. And then we have the structural fix, right? We restored the structure onto the UAT. We ported some of the dummy data into the UAT, and the code functionalities was tested by the application team, and data consistency validation is done, and they did a series of load tests with respect to the application, how the load behavior is there, and uh, is there any furthermore indexes, or how basically they perform the load comparison and performance comparison between Oracle and Postgres and certify that. Okay, so this is the important part of migration. And other some of the best practices to do the bulk loading. Okay, so first thing is disable the foreign keys. So we disable the foreign keys at the target side, and then after the load is completed, means that is the full load is completed, we started creating back the constraints. So this is to avoid the blockage or the breaking of DMS with respect to the FP constraint failures. And then the thing is load the references table first and then the master table. Okay. And high volume tables, right? As we defined, high volume tables, we defined as a separate task. Uh, there is a workaround for this as well. I'll just explain the coming slide. And for LOB tables, get the exact LOB size from the Oracle side. Okay, and then choose the limited LOB option in the DMS task and have means a buffer of 30% from the size. Let's say to accommodate the surprises as well. For example, their sizes may not be accurate or what we get. So to handle that, if you go for a limited LOB will be fasterly restored by the DMS task. Okay. Enable validity constraint. That means the count matching features. When you see the task, there you can see in the logs. You can see the count validations. Next thing is the how did we perform the cutover? Now we have the data. That means we have the data in uh, Postgres, and we define the cutover strategy as well as the rollback strategy. That is during the time of cutover. The first thing is during the downtime window. We took close to 4 hours of downtime window for this. First is the write phase. That means we stop the writes on the Oracle completely. The application will be stopped, and then ensure no writes happen. The application Oracle team will confirm it, and then give a 15 to 20 minutes on the Delta sync. That means CDC has to sync back on the 15 minutes of data, which has come recently. And next comes the validation part. Validation part is nothing but we take a complete count from the Oracle. and match the same count with the Postgres. In certain cases, DMS also has failures. That means the incremental data may not be syncing in certain cases based upon the table. In those cases, we have to do a full loading. So that cases basically we face the issue on tables with a non-primary key table. Even with non-primary key table and supplemental logging enabled at the Oracle side, DMS sometimes fails to have a CDC data for those tables. Those tables we don't have any option. We have to do a reload. That is the option. And next thing is the sequences. The sequence is handled as an object in Oracle. So we have to get the last sequence from Oracle and prepare an alter statement accordingly and reset the similar sequence on the Postgres side so that the ID conflicting or to know the point from which the Oracle started getting the right site, it is easy to track. So we'll have like get the last sequence from the Oracle, add it by 1,000 or 2,000, like have some gap and start it from the Postgres so that we know from this point Postgres write has happened and from till this point it's Oracle write. So this will help in rollback as well as the if need of a rollback, right? This is very helpful and start the application onto the Postgres and monitor the means do a smoke testing, start the application. It's not a live traffic yet. So we did a smoke testing. The application will do the functionalities code. It's a normal procedure. And then once they certified, the go live is announced. And this is a cutover strategy which we followed. Okay. So next is a rollback trigger. So what are the things that defines the rollbacks? Under what scenarios rollback has to be initiated? Okay, like a critical application failure means the certain application codes or the critical business codes does not work. Uh, Data mismatches, like the float of weight or the precision value mismatches, critical things, and performance degradation, like production load is not able to handle with respect to the Postgres. That triggers a rollback strategy and also functional defect, obviously. Okay. The important thing to note that is like once these issues are caught at smoke test or the functional test, the rollback is straightforward. Once Oracle, that is Postgres, started getting right, the rollback is pretty tricky. They have to get the sequence ID from those points and then do the rollback or reversing, and then you have to configure a replication back from Oracle to Postgres, right? So once the Oracle gets the right, and there is, uh, I believe, you should not go back to, sorry, once the Postgres gets the right, you should not go back to Oracle. That is end of life cutover is done. But if you still wish to proceed to means rollback, that's a difficult path, I would say. Okay. Next comes issues and workaround. So one issue which I have already mentioned, that is the precision value issues which we faced. And another thing is by default, uh, DMS uses a single thread architecture, or when you have a bigger table, let's say in our case, we had around 10 billion record on a single table, for which the active data set is around 2 billion records. But obviously, after cutover, we have to migrate all these 10 billion records. For the initial, we started a DMS task like with the default, or we added the transaction commit size as 50,000 per commit, and we started the task. The task was running. Uh, it started running, and the load time was pretty slow. In certain cases, when you had multiple DMS tasks running at the same times, we had seen failures also with this particular task. So the loading time with respect to the window time post 35 hours, then it has to sync back the uh, archive logs or the change logs from the Oracle side. This is a highly transactional table. So during that time also we had expiration of archival logs and this task completely finished. Again, we had to do. So we have done means couple of iterations and it was failing. And even when I succeeded time, it was taking around 35 hours for this table. So then we explored and we found that there is a feature in DMS that supports parallel loading. Parallel loading is like you define the ranges for table. You split the table into multiple ranges according to the primary key of the table or the sequence key of the table. And then for each sequence or each range, you allocate a thread on the DMS and then you start the load from the DMS. In this case, The important caveat from here is you will have a higher thread utilization on the replication instance. On the DMS, we have a replication instance. We have to upscale the replication instance. On the other side, when the same load goes to the Postgres or the Aurora Postgres, you'll have higher CPU utilization as well as the IO utilization. Okay, so this is the boundary definition. Like for one of the tables, we have this. Sorry. So this is the schema name that is prod. For example, we have the table name is task and the sequence column is task sequence. We created the boundaries, like this is sample boundaries. In production, we had each boundary is defined as 20 million, each boundary, and we defined the threads as we had given around 32 threads in total parallel threads. For per transaction commit, we have given 50,000. So with this, the 35 hours get reduced to 4 hours. But obviously, the thing is, we'll have the higher CPU utilization. We have to use a higher instance type on the Aurora side. And that is the next case. Okay. Okay. I think we are almost um, for the data migration, right? Plan the parallel load means we have taken a wrong strategy in the beginning. Like we can load, but plan the parallel load based upon the table size from the day one, so that your time is saved. And the sequence reset should be done as a cutover activity, not as a post cutover activity. Before the application getting started on the Oracle, sorry, Postgres side, you have to do the sequence reset. Okay. And for faster reload, we already discussed FKs has to be removed. And one more thing, indexes. Let's say with the indexes, the loading will be slower because of the index page writes and multiple reasons. So after the full load is completed, we have created the index separately onto the Postgres instance. Thereby also we save some time on the Postgres migration. And post migration, like post cutover, so the hypercare window is very, very critical. Like the next 48 hours, like in hospital, right? They say next 48 hours and next 24 hours, very critical because you might be doing the cutover on a low peak window. But when the actual traffic starts, you will see the actual behavior in the real case scenario, how this on concurrency, what is happening. So to handle this, so we had estimated something around 2x large machines. So we upscaled it to 8x large in for the first day of cutover, and then we estimated like around two replicas. We added two or three more replicas and also auto scaling onto the Aurora part to handle more of the load. Even if it is wastage, we do not care because we do not want to have the um, cutover as a failure. We want then we have to work reversely. Like for example, uh, there might be cases where it is missed, like that was working fine in the UAT and load test. There are certain cases production is always special. So some kind of glitch may be possible. Obviously, we had to in our production, like certain indexes or optimizer plan did not work properly. We had to create some more indexes based upon the use case. We did on the next 48 hours and made this as a successful migration. Yes, this is the end. Any questions?
Nice response. I have a few questions. Uh, After the migration, that Oracle have some individual uh, how you overcome that features in Postgres? What type of extensions you have used? Like in Postgres, Oracle have GTT tables, like the global temporary table.
Mhm.
Like same like that, we have how many extensions you have used it to overcome that extra features?
Okay, so extension we used majorly because also it is a Aurora managed Postgres, right? So there are certain restrictions on the extensions. All the extensions cannot be used in Aurora PgSQL. The first extension which we had right in Oracle, we have schedulers. Okay, so the automated job will run automatically. But in Postgres, we had enabled pgcron specifically for two purposes. One is the one is for the jobs which we had migrated from Oracle, and the other is the refresh of MVs, which we have used PG crawl. And we had the foreign data wrappers as well, like to sync the data from the current Oracle to Redshift to satisfy the analytical use case. Yeah, majorly these are the two extensions which we use.
Kabilesh, I would like to answer a question asked by Lokesh. Okay, so he asked like there is a concept of global temporary tables in Oracle, so which we can store definition inside a database, right? But here, Lokesh, what you can do is you can create unlock tables in Postgres just so that it will not create right ahead of logs. Okay, and whatever operations that you are doing on global temporary tables you do on unlock tables and then truncate that data. So your definition will also get stored and then you will have that advantage of global temporary tables also. Okay. So I'm using that now. So that's why I informed it. It will be useful for all of us. Yeah.
Yeah, thank you, Tejas.
Yeah. Sure.
Yeah, Kabilesh, excellent presentation. What were the boundaries? Were they auto-generated by DMS, or did you folks determine the start and end boundaries?
Yeah,
Thank you.
this was not auto-generated sequences. So these boundaries were generated manually. So getting the min sequence and the max sequence, the primary key, we generated the boundaries like 20 million was the boundary range which we defined for this 20 billion tables, like 24 tasks, like 24 boundaries we created. And per task, we, as I said, right, we had for this particular task, we created 32 threads to parallelly load those boundaries in.
And what was the Postgres? Since this is a managed instance, did you have any ability to configure any conf related configurations for the shared memory or anything like that, or give anything for performance benefits?
Sorry. So this is a managed thing, right? So most of the it's a Aurora basically. It's not even a RDS. It's a Aurora. So we have all this shared buffer. Everything is tuned already. Most of the cases, and in some cases they do not allow you to change the parameter in Aurora. So that is true. And certain parameters which we have changed as per the application need. That's all very minor, not a major performance related.
Awesome. Thank you.
Yeah, Kabilesh, one more question I have. You have mentioned 20 terabytes of data migration, right? And only you are migrating last 6 months of data using the DMS. The same thing I have also used it. You using the Oracle PG last 6 months data. Some of the very basic like one table last 6 months data only I have migrated. Like yeah, how much for after migrating the 4 TB of data, how much time it will be taken?
You mean for the replication you're asking, or
Uh, no, data migration only.
mm.
How
See,
much time? How long time?
so data migration we have done in multiple phases. Okay, so as I said, right, we segregated the tables based upon the size and the complexity. Like LOB tables, we created a separate task. Okay, we do not do the all the loading at the same time because it can cause back pressure both on the replication instance of DMS, also the resource pressure on the Aurora side. So we did a phased migration. Like once the CDC of the first task, like we are doing, right, post completing of CDC. That means once the CDC starts, the load will be reduced, post the full load, and then we started the next task. Even for the transactional tables, right, the bigger tables, that's what I said. We had for a single table, we do not measure the entire migration size because this migration was running for more than 1 year plus. So we cannot say a definitive time this much time for complete load, right? Complete full load. To answer your question on a rough estimate, it took around close to 1.5 to 2 days for full load, and CDC is ongoing.
Thank you.
Kabilesh, there is one question in the chat. I think you have answered Anil, but there is a question from Gangadhar. What was the rollback plan in case any issues surface after the cutover, after a few hours of cutover? So if you can answer that, it would be great.
Yes. So as I said, right, um, after few hours of cutover, we means there is no rollback. As if you say upfront, there is no rollback plan for this. So only if there is a we define the rollback in two phases. That is, application team does a smoke test and functionality test. After certifying, we go for a cutover. That is production. We open the production traffic. If there is a failure at the smoke test or the functionality test from the application side, then we roll back directly back to Oracle. There is nothing like we have the sequence, right? From the last sequence, it starts running. There is no issues in that. But having said that, after 1 hour of thing, right? 1 hour of having a partial data on Postgres, it was never in the plan. There is no rollback. It's a kind of a suicide because half data will be here. Only in those cases, application team will be the right person to decide which data has moved come here recently, and they have to replay from the application. So that is the one option I can see. The other option, what we decided was we can have a because the structure is common in Postgres and Oracle right now. We can have a reverse replication. That means reverse incremental task based upon the sequence number, or only for the major tables, not for all the tables is not possible. Only for the higher transaction table, we can have a reverse replication using same DMS, creating a task as Postgres as a source and destination as the Oracle and sync it. So this is a very edge case rollback which we decided, but it was not implemented.
See, hi, this is Gangadhar again, related to the same question. So when you said for the larger table, you divided that into multiple threads. On that time, we need to consider performance hit on Oracle as well, right? So when I have more threads, definitely it's business as well systems get into.
Exactly. So thanks for that question, Gangadhar. We exactly face the same issue, even though it is a rack cluster, right? So initially we were using the same rack endpoint, that is the first endpoint as production. So when we started using, Oracle was going to 80%, 90% CPU. So it was a near downtime for the Oracle cluster. So then we had to stop this migration in between, and then we configured a secondary inputs. So we had a second rack cluster, right? And also they had certain read endpoint as well. Okay, like readers. We started using the readers to avoid this situation.
Okay. So in a bigger table, you mentioned, right? Okay, consider that is a 10 billion table. You had to consider for easy understanding 10 billion into 10 threads. Okay. That was when you divided 10 thread. But when active transition keep on going, right? When you divide 10 billion into 10 thread, right? 1 billion. Oh, you set a boundary for first thread as a 1 billion end. But during regular transaction, right? That thread may become 1 billion plus few extra. Then how are you controlling that? I cannot say that, okay, during migration, my sequence should not change, or number of records should not change, or increment or decrement.
So that is managed by the DMS. So DMS has a checkpointing option. So it does the checkpoint frequently. And let's say during the ongoing transaction, if there is a change or a update statement which is coming for a particular sequence, that is retrieved from the archive logs as a part of the ongoing transaction. Those changes are applied to the destination.
Okay. Okay. So what are the logic we use to divide that? That should be a unique key.
Yeah, that is a unique keys. Those are based upon the primary keys.
Okay. So, okay, what if that larger table doesn't have that kind of a uniqueness? Then how do you divide that and conquer?
If there is no uniqueness, right? This sequence is supported only on the primary key. Okay. If there is no primary key or a non-integer primary key, there is no other option. So we have to either you can go for a condition-based migration, wherein you can define certain tables. Even in condition, it will be a direct condition with var class, not like subset of class joining is not supported in DMS. You can do that, but this parallel loading is not possible.
Okay. When people look for migration, right, they will try to look for reframing their architecture or re-architecture, they may consider to do somewhat database changes here and there to match current demands, right? And that time it is not like apple to apple migration, right? In the source, you may have a 2000 table. When you are re-architecturing or reframing to match what are the latest features or latest application, right? And that time you may need to have more table on the target, or you may need to have less tables or divide larger table into multiple tables, okay, to accommodate the latest frameworks, the latest technologies. Right? And that how was that challenges?
So, Ganga, to answer the question, this is basically an application call. So, primarily an application call. So, as a part of re-architecture, they can split the. We also did some re-architecture, like they had split some of the tables into other microservice architecture. So, they moved into separate tables or separate servers altogether. But the core application, right? The core application is not splittable. So, they said we want the same core functionality to be moved. So we did this migration. What I speak of is a core functionality. The small web applications, they were moved out of this monolithic Oracle database. They are moved into separate RDS, standalone RDSs, and they migrated it. But for this core functionality, it is not possible from the application side.
Oh, okay, thank you. If they want, then they can make those changes after migrating to the cloud latest.
Yes, maybe that will be a next phase of that.